today's video, I'm going to show you the tutorial of T flip-flop. So first, what is T flip-flop? T flip-flop is an essential triggered device. In example, the low to high or high to low transitions on a clock signal. Narrow triggers that is provided as input will cause the change in output state of flip-flop. Next, what is the characteristics of T flip-flop? T flip-flop, the essential characteristics of a flip-flop is that it changes its output state in response to a positive or negative transition on the control signal. But there is more to a flip-flop than this. We also have to define the input to output relationship. Next is the components to use in T flip-flop. So we have VCC source, ground, 4-3 terminal AND, and 4-2 terminal AND. We have 4 switch, 1 NOT, and 6 probes. So next, I'm going to show you the logic symbol of T flip-flop. So this Q, this is the output, and this one is the inverted output. This T means the toggle, and this CLK means the clock. So next is the logic diagram. The J and K are connected so we can have the T or the toggle flip-flop. And this connection is the clock. So next is the truth table. So if the clock is 0, that means that there is no clock pulse transitions. And if the T is X, X means that either 0 or 1 is a valid value. So the output is Qn plus 1. So the output is Qn. That is mean hold. And if the clock is 1, that means that there is a clock pulse transitions. And if the T is 0, the output is Qn or it is hold. And if the clock is 1, it means that there is a clock pulse transitions. And if the T is 1 or the toggle is 1, the output is toggle. So next is the characteristics table. So if the Qn is 0 and the toggle is 0, the output is 0. And if the Qn is 1 and the toggle is 0, the output is 1. And if the Qn is 0 and if the T is 1, the output is 1. And if the Qn is 1 and the T is 1, the output is 0. So this time, we are going to show you the excitation table. Excitation table depends on the characteristic table. So if the input Qn plus 1 is 0 and the input Qn is 0, the toggle is equals to 0. So let's check on the characteristic table. So if the Qn plus 1 is 0 and the Qn is 0, the toggle is 0. So this you can see in the excitation table, it is the same. So if the Qn plus 1 is 0, the Qn is 1, the toggle or the output is equal to 1. So if the Qn plus 1 is equals to 1 and the Qn is equals to 0, the T or the toggle is equals to 1. If the Qn plus 1 is equals to 1 and the Qn is 1, the toggle or the output is equals to 0. So that's how excitation table works. Next is our simulation. So we will be using the electronics workbench to simulate our T flip-flop. So this T flip-flop is made by JK Master's Slave flip-flop with 2 asynchronous active below low inputs. So the preset here makes the output high and the CLR here makes our inverted output high. So let's start the simulation. So let's try to put the preset and CLR. So as you can see, the output is toggling. It is because our T flip-flop is not initialized. So because it is not initialized, we are going to initialize the T flip-flop. So to make it initialize, we are going to forcefully make one output high. So for example, let's have our preset. So now, our output is high. Next, we will be going to toggle the output. The T flip-flop will be initialized. Let's turn on the toggle and make a clock pulse signal and turn off the preset. And now, as you can see, we have toggled our output. Our T flip-flop is initialized. So, let's demonstrate the functions of T flip-flop. So, the first one is the toggle input is low. Then, there must be no changing in our output, as you can see. So, since this T flip-flop is master-slave, this is a negative edge triggering in flip-flop. And if the clock goes low, the T flip-flop operates. So, let's try. So, there are no changes in the output. So, if the toggle is high or 1, and every time the clock low, the output toggle. And if the clock input high and low, so the output toggle. And if the clock is low, the output toggles. So, that's how the simulation works. Thank you. And thank you for watching.